So we have the numerator 10 to the power negative 3 divided by 1 times 10 to the power negative 6 is the same thing, but it's in kilogram. This is a 10 to the power negative. This is also in meter cube. In this case, when you have A over B, A to the power M, okay, divided by A to the power N. This is A to the power M minus N, isn't it? Isn't it?
Yes, it is.
Good. So let's apply it here. It means we have we come in. So it means we have 10 to the power negative 3 minus 6. 10 to the power 6 minus 3. And this is equal to 1000. Or 10 to the power 3, which is equal to 1000 kilogram per meter cube. All right. So that's how to convert this. Another way. Can I clean this?
Yes, please.
Another way is this. As for the numerator, 1 gram would be equal to 1,000 kilogram. But we are talking about 1 gram per cm cube, which is equal to 1 gram over cm cube. So we are converting centimeter cube to meter cube, right? Now, 100 centimeter is equal to what? What's the equivalent of 100 centimeter in meters?
1 meter.
1.
So this is 1 meter. So this implies that 1 centimeter, or this 100 is actually equal to 100 times 1 centimeter, which is equal to 1 meter. Therefore, 1 centimeter is equal to 1 over 100 meter. Please, are we correct? Are we okay?
Yes.
Good. Then look at something. This is line. I need volume, so I'm looking for 1 centimeter cube, and 1 centimeter cube is actually 1 centimeter by 1 centimeter by another 1 centimeter. I've just had the equivalent of a centimeter in meter. So it means this is equal to 1 over 100 meter times another 1 over 100 meter times another 1 over 100 meter. So in effect, I have 1 over 10 to the power what? 10 to the power what?
6
meter cube, and that is the equivalent of 1 meter cube in 1 centimeter cube in meter cube. So all that I do is to bring it here, knowing 1 gram to be 0.001 kg. Then 1 centimeter cube would be, okay, let me express that in standard form so that it becomes a bit clearer. This is 1 gram over 1 cm cube. So you have 1 times 10 to the power . Akosia,
Mr. Edia, please, you said 1 centimeter cube is equal to 1 centimeter times 1 centimeter times 1 centimeter.
yes.
So the 1 out of 100 meter times 1 out of 100 meter times 1 out of 100 meter, is it not equal to 1 out of 100 meter cube?
Oh yes, it's the same thing, but you see, because I'm teaching, I'm giving you that systematic way of, because you have understood it easily that this will be 1 over 100 meter all cube. It's true, but somebody, when you present it like that, somebody may not see it unless you break it down systematically in this form. Okay.
Okay, sir.
Yes. So this is the same as 1 times 10 to the power -6 meter cube. So you have converted 1 cm cube in meter cube, which is this. You've converted 1 gram in kilogram, which is the divide, and you can easily do that. So that's the trick in this conversion. Are we okay?
Yes, please.
So when you are able to master this systematic way of doing it, whichever question you are given, you can be able to maneuver your way out, right? So please let me take part of your time to finish this work. So because the metal is submerged completely in the water, the volume of water displaced is equal to the volume of the metal. Now look at it. We have its mass, we have its density. So using density is mass over volume, you can easily find the volume, which will be mass over density. So the volume becomes 1 kilogram divided by 2,700 kilogram per cubic meter. And what is 1 divided by 2,700?
3.70.
3.70 times 10 to the power
3. -4.
-4. Okay, 3.704. Okay, then gravity is 10. So when you put them together, you see, this and this will give you 10 to the power 4 times 3.70 times 10 to the power -4. This and this will cancel out. So the upthrust is 3.704. Akosia,
Mr. I thought you said we are not using the density of the metal, we are using the density of the liquid.
no. Akosia, now we are looking for the volume of water display. Okay.
Yes, so
Good. Because the metal is completely immersed in the liquid, okay, the volume of the liquid displaced is equal to the volume of the metal. Are you okay?
so this one, my question is, we are finding the
Upthrust.
yes,
We are finding the
and we are using the volume of the liquid.
yes.
But so why you not using the density of the liquid, but you are using?
I will show you are confused. You see, upthrust is equal to rho kg. Well, rho is the density of the liquid. The liquid is water. Its density is constant. 1,000 kilogram per meter cube. Okay. Then the volume of the liquid displaced. The volume of the liquid displaced is always equal to the volume of the object submerged in the liquid. Okay. The object is completely submerged in the liquid, meaning its whole volume is within the liquid, isn't it?
Yes, please.
Good. So if we are able to, we can find the volume of liquid displaced when we have the volume of the object. Okay. When we have the volume of the object, we can determine the volume of the liquid displaced since the object is completely immersed in the liquid. Akosha, are you okay?
Yes.
Now, what do I have? I have the density of the object, which is 2,700 kilogram per cubic meter. I also have the mass of the object, which is 1.00 kilogram. Akosha, can't I find its volume? Can't I find the volume of the object?
You can.
And once I have the volume of the object, what do I have?
The volume of the water displaced.
Exactly, because it is completely submerged. So I determine the volume of the object, which is its mass divided by density. So 1 divided by 2,700 give me 3.704 meter cube. Which this is the volume of the aluminium, and so is the volume of the water displaced when since the aluminium is completely submerged in the water. Are you okay?
Yes, please. Thank you.
Good. So 1,000 times 3.704 times 10 to the power negative 3 times at least is it negative 4?
Yes, please, it's -4.
Negative 4 times 10. 10 is gravity D. So when you put this together, you have 10 to the power 4 times 3.704 times 10 to the power negative 4. This and this reduces to 1. Okay, 1. So we have the answers to be 3.704. Then subtract 3.704 from 10. Let's subtract that from 10. And this should be 6 point.
6.296.
Okay, so approximately 6.3 Newton is the tension in the string. Okay. Class, are you fine?
No, sir, Mr. Dear, but from the 10 raised to the power 4 times the 3.704 times 10 raised to the power -4 times another 10. That's the gravity.
Yes.
The 4 cancels the -4. So
Yeah.
it was left with 3.704 times 10.
No. You see, the density of water is this. The volume of water display is 3.704. Okay, times 10 to the power -4, then times gravity 10. Okay.
Mr. Dear, I don't understand.
Okay. Zuviel,
Thank
Yeah.
you.
Zuviel, I saw your hand up.
Mr. Dear, please, I wanted to ask that with some calculations, when you divide 1 by 2,700, it gives you 0.37.
When you divide 1 by 2,700. Hello,
Mr. Dear, I can't hear anything.
Zuviel. No, that's wrong. When you divide 1 by 2,700, it should give you a value far, far less than 0.37. Okay. All right. So we'll have another session tomorrow. Okay. So let's end today because I'm sure others
So
have
why is
lessons.
the 3? It's 3.7 in the expression.
No, Zuviel, when you divide 1 by 2,700, it should give you a value far, far less than 0.37. That's why we had 3.704 times 10 to the power negative 4. And this 10 to the power negative 4 is actually 0.00037. Okay, which is far, far less than what you said. Okay.
I've understood.
Yes. Please, I think our time is up. I'm sure others have lessons. So, Akosia, you can send your questions personally to me, or you reserve it for tomorrow. Okay. Okay. So, this is where we draw the curtain on today's meeting. Bye bye.
Bye, Stadia. Bye bye.